So the product of two consecutive natural numbers which are multiples of 3 is equal to 810. You want to find the two numbers. Now, if the question was just dealing with the two consecutive natural numbers, I would have considered them to be x and x plus 1, because they are two consecutive natural numbers. One would be x, the other one would be x plus 1. Here, however, there's a slight change. They are said which are also multiples of 3, right? So for this condition, right, so if there's a multiple of 3, instead of taking it as x, I'll take it as 3x, because anything which is a multiple of any number which is a multiple of 3 can be taken in the form as 3x. If it was a multiple of 2, I would have taken it as 2x. Anyways, so it's a multiple of 3, so I can say let the two natural numbers be 3x, and now understand, if one number is 3x, the next natural number which is a multiple of 3 will be 3x plus 3. Why plus 3, you may ask? Because understand, what are the multiples of 3? 3, 6, 9, 12, 15 and so on. And between any two consecutive multiples of 3, the difference is 3. So if the smaller multiple of 3 is 3x, the one after that will be 3x plus 3. Right, so the two natural numbers will be 3x and 3x plus 3. The condition given to us is that the product of these two natural numbers is equal to 810. So which basically means the product, so 3x into 3x plus 3 as the product of the two natural numbers, that is equal to 810. Yeah, that's what they've given us in the question, and that's basically our equation here. We just need to expand this, get it into a quadratic equation so that we can solve it more easily. So you use a distributive property. 3x into 3x makes it 9x squared. 3x into 3 will make it plus 9x is equal to 810. We'll shift the 810 to the left hand side of the equation. So I have 9x squared plus 9x minus 810, sorry, 810 is equal to 0. So here, as you can see, I've got my quadratic equation in the standard form. Okay. However, if you see the coefficients or the numbers more carefully, we have 9x squared plus 9x minus 810. Now, all of these three numbers, 9, 9, and 810, are divisible by 9. So let's factor that out. Let's divide the entire equation by 9. This will make my equation a little easier to solve. So 9x squared upon 9 will become x squared plus 9x upon 9, which is plus x. And 810 upon 9 minus 810 upon 9 will be minus 90. 81, 9's are 81. So yeah. Okay, so this is the final quadratic equation which I will be solving, by splitting the middle term by the factorization method. The product that I need, right, is 1 into minus 90. So the product should be minus 90. So I need two numbers which multiplied give me minus 90, and their sum should be equal to 1, right, 1x. So two numbers multiplied to give me negative 90, and when they are added should give me plus 1, is 10 into minus 9, right? 10 into minus 9 is minus 90, and 10 plus minus 9 will give me plus 1. Those are my two numbers. So therefore, x squared plus 10x minus 9x minus 90 is equal to 0. Right? That will be my, that's how I'll split the middle term, right? Now, let's start factorizing it. Between the first two terms, if you notice, we have x, which is common, so I'll take the x outside the bracket, and I'll be left with x plus 10 inside the bracket. Between the third and the fourth term, I have a minus 9, which is common, and I'll be left with x plus 10 in the bracket once again. Okay, and all this is equal to 0. Okay, now if you see, we have x plus 10 and x plus 10 common, so let's take that outside, and I will be left with x minus 9 in the bracket, and product of these two terms is equal to 0. So next will be the zero product law. Since the two numbers multiplied equal to 0, either I can say x plus 10 is equal to 0, right? Or I can say x minus 9 is equal to 0. So let's solve these two equations now that we have. Therefore, now if I'm solving this first equation, x plus 10 is equal to 0, take the plus sign to the other side, becomes minus. So x is equal to minus 10. Or if I solve this equation here, take the minus sign to the other side, becomes plus, so x is equal to 9. Now, in our question, we've been told that x is a natural number, or rather 3x is a natural number. So if you're multiplying 3x with, if you're multiplying 3x where x is minus 10, you'll end up with negative 30, which is not a natural number, right? So therefore, since the numbers have to be natural, and since the required numbers are natural numbers, x is equal to 10 will need to be rejected. X is equal to minus 10, sorry, is rejected, right? And this gives us the answer that x should be equal to 9. Now, don't stop here. Even though we found the value of x, remember, we want to find the values, the variables that we've taken, the numbers, the natural numbers that we've considered, which are multiples of 3, have been considered as 3x and 3x plus 3. So we've got x is equal to 9, right? So therefore I can say that, therefore 3x would be equal to 3 into 9, which is equal to 27, and 3x plus 3 is equal to 3 into 9 plus 3, which is 27 plus 3 is 30. So the two required natural numbers which were multiples of 3 are 27 and 30. That will be our final answer, right? So therefore the required numbers, natural numbers, are 27 and 30, and this is my final answer.